Alrighty, here we have video 115. We're talking about the introduction to Venn diagrams. This is one of the nice things that you start to do a little bit in Math 20, and you do a little bit more in Math 30. So the more that you can get in Math 20, the easier Math 30 is going to be. How's that? So not all proofs can be done using variables. One way to solve those types that don't include variables is to use a Venn diagram. It's basically this circle diagram. You've probably seen them before. You may or may not have called them Venn diagrams. So with one circle, there's only three options. You could be talking about the universal set. Okay, and the universal set is everything. So if we think of this as our set, the universal set is kind of what's inside the circle and what's outside the circle. That's it. Now, I bet you are clever enough to figure out what I should color if I'm coloring A. Yeah. You can be better than me and do a nicer coloring job, but that's good enough. Now, A prime, right? Not A apostrophe, certainly not A comma. I've had somebody tell me that, and I'm like, no, commas are down at the bottom. This is apostrophe. But in math, we don't say apostrophe. For some reason, they decided it's called prime. So what's the only thing we didn't color yet? We colored everything. We colored inside the circle. Well, A prime is outside the circle, or oval. So that little prime mark there means not. So basically this is not A. All right, and y'all can thank my son for the next question. I can't remember what it was, but he started calling me a potato, and I looked at him like, what? He goes, well, everything in the world is either a potato or not a potato. So mom counts as a potato. I don't know if that was a good thing or not, but apparently I'm a potato. So draw and label a Venn diagram. Well, these are the potatoes. And what's outside it? Not potatoes. And the universal set would be the world. Everything is either a potato or not a potato. Yeah, seriously, that's as much as we can do with one circle. We want to call this P, we would call this P prime. And this would still be U for universal set. Just saying. Okay, so I don't know, you choose. Are you a potato? You're not a potato. When you have two circles, it's a little more interesting at least, because you can have some variations. You can have, which are called mutually exclusive or disjoint sets. You can have an intersection and you can have a subset. I bet you could probably guess one, maybe two of those. I think this one's the easiest one. Because if I have a circle and I have another circle and they need to intersect. So this is the intersection. So these two things have, whoopsies, not have some things in common. So if we make this cats, make this dogs, then cats go meow, dogs go woof, and they both have tails. Okay. Only cats go meow, only dogs go woof, but they both have tails. You can put more stuff in there, but there you go. Okay. Yeah. If that's intersection, disjoint sets and subset. All right, so I'll let you know. A disjoint set have nothing in common. So an easy one. Even numbers, good odd numbers. So what's left? What's the only other way that we can have two circles? Now one circle, and the other one inside the circle. So this part is called a subset. Now, I was going to write have everything in common. That's not quite right. Because if they had everything in common, then they'd be the exact same set. The subset, sorry about my phone, is part of the bigger set. So if we have, let's go humans, and we put men. There you go. That's an example of a subset. So with two circles, 3 circles is in biology. Nope. Sorry, it's in math 30. But we have 2 circles like this, nothing in common, something in common, and completely inside. So there you go. That is the end of that video and the beginning of Venn diagrams.